like to introduce myself. My name is Alex Gonzales. I'm a program manager doing work for UT Austin as a commissioning authority. I've been working there for many years, and hopefully today we'll have some interesting points to make to you. My experience as a owner rep, a commissioning authority, and basically being a good value-added consultant to owners. I think some of the concepts that we're going to try and present to you today will register in a good way. So I'd like to let my team introduce themselves.
Hello, my name is Jessica Duenas. I'm a mechanical engineer and I work for our Austin office.
I'm John. Sorry about that. I'm John Bixler. I work out of our Cedar Rapids office and do a lot of work with the University of Iowa, but connected with Alex and Jessica and their team over the past couple of years and helped them out on this particular project that we're going to kind of highlight later.
I'm Adam Keeling. I work at the University of Texas, so I'm the client here, and I'm with the Utilities and Energy Management Department, and I'm the campus energy manager.
So with that said, we'll get going. I'm going to hop along here a little bit. I have a rough leg, but I've been surviving, and just so you know, I'm not going to fall down. So, our course description, examination of the needs of an institutional client, the gap left by the traditional new building commissioning process in terms of the handover. The University of Texas has been working to revise the requirements of how commissioning providers can more support the turnover phase, right, and warranty to also assist them in their optimization efforts. And as far as changes and how that relates is kind of bridging that handoff from the project delivery team to the O&M team, and a stronger focus on the warranty period. I think we can all say warranty periods and when they start and just how much we're done or how many levels of done we go through in the warranty phase. I think we can all connect. And the particular expertise that the commissioning authority has to really help that handoff, and some of the concepts that I think that we'll talk about is, you know, one of the key roles for the commissioning providers. How many of you here are, well, most of you are probably commissioning providers, so you can raise your hand. Okay, who is not a commissioning provider? Owner, consultant? Okay, so hopefully we give you some tools here to try and look at a little different of how you can leverage your commissioning authority in that handoff. And so our learning objectives, well, the first one is understand the needs of an institutional client. You know, higher ed clients in terms of their needs for long-term operational, how things are being handed off to them. Institutional clients that have large campuses, multiple buildings, you know, they have different needs from when we have one standalone kind of client. We're going to learn about value-added methods for how the commissioning authority can be more involved in the warranty process. In my experience, almost 30 years, most of my career, when I look at things from the owner's perspective and how he sees when warranties start and how contractors are turning things over, and as a team, the project delivery team, that warranty process is a really critical time for them. And to understand what the CXA can do in the warranty phase, I think we're going to make some references to Lead V4 and how Lead V4, in my opinion and in many others, I think has hit on some really good things in terms of improving that handoff. So in Lead V4, the monitoring-based commissioning point that's out there now that I think a lot of us recognize has some hints of a lot of areas where, again, that handoff and how the O&M guys are trying to get the project from the project delivery team and how we can supplement that handoff. And the measurement and verification results. Most of you as commissioning providers, you probably know that from Lead V3 to V4, that old M and V point has disappeared. But what has it evolved into, and how does the verification side, which in reading lots of information about how V3 to V4 happened, they were looking at our owners following through in that verification process. Or were we just writing a plan to say that we'll do it, but they weren't doing it? And I believe that some of the things that we talk about today will kind of register in how that improvement came to be. So Juan Ontiveros, who is the Director for Utilities and Energy Management at UT Austin, also oversees the Facilities Management Group. Him and I sat down several months back, and I'd written these up based on some correspondence that we had had in the past about what his needs are from his perspective. Sat down with him a couple months ago and said, hey, I'm going to present these. Tell me, are they good? Are they right on? And he added the last one. But let's go through them. I mean, owners' O&M requirements need to be clearly understood. The point about LEED formalizing OPRs and BODs, to some people that don't understand architectural design, they kind of go, why do we need that? Well, we need it because the owner needs to get all those requirements out there. And our role as a CXA, we do a lot to get those incorporated into that OPR. It needs to be up front so it's carried through. The commissioning process milestones integrated into the project delivery process. I've experienced design build projects, CMIT risk, design bid build, and all of those different project delivery processes require us to make sure that as a team, we've got the proper milestones in there. Well, for commissioning, really important milestones, right? Not just to get the functional testing, but to get the training, the tab, all of those things that relate to the commissioning process that we hope the CM is really putting realistic timeframes and including it in there. So from an owner's perspective, we want to make sure those are in there. The project delivery accountability, his exact comments are, need to hold the designer accountable, the contractor accountable, and my staff who's taken over the building accountable. Well, that's a good view, that's a good way to look at it. And accountability for performance, that we're really turning over a building that's going to perform at the level that we want it to. But in order for that to happen, the O&M staff have to be able to be ready, comfortable, and know what their role is in keeping it performing high. So commission systems and not just equipment. We're going to address here in a little while about what happens when phase turnover starts happening to a project, and how that phasing from an architectural standpoint, I can say this room is finished because I don't see any blue tape, but what I don't see is the systems are not to this room only, the systems are building wide. So looking at system level and how that's going to be maintainable and energy reliant, as Adam is going to cover here in a little bit from his perspective of what his group is doing. Initial commissioning process from design through warranty, and confirm the owner's requirements, the design requirements have been met before the team leaves. How many of us have experienced where, we want to hand it off to the owner as a project delivery team, but we also recognize, and me personally in my owner experience, that CXA and his skill set and what he knows about my building and what he can do to impact learning and training opportunities, supplemental to what the contractor is doing, is a huge value. It's a huge value. And for Adam's team, who does a lot of that analysis, sometimes they got it all. They got it figured out. But when he needs help, we're able to come to the table and help supplement that. So the improved handoff. Technology now is driving everybody crazy, right? How many of you guys see those O&Ms, those PDF documents that are 900 pages, And the CM says, I got it all here, here's a drive, you take it all, and how do you make sense of that for the guy who's trying to read and know how to access that information? So what is the improved handoff opportunities and documentation, and how to mitigate that fire hose effect? That's a very common term that I remember an owner telling me in an interview one time. going after a job, and he says, you know, I really like what you're talking about in terms of supplemental training and trying to keep that fire hose from hurting my guys, you know, they just can't take it. So we're going to talk about that. Post-construction and ongoing commissioning. That last bullet that Juan added was in context of, from his perspective as a campus, it takes 2 years for them to really realize the full load on that building, the design intent. So it's the warranty year plus another year. And in those 2 years, there's things that are going to happen. They may decide to change a schedule for how they use a particular part of the building. They make certain changes. So that help for ongoing commissioning is just a natural part of what we as CXAs can provide. So, okay, as commissioning providers, we've all seen these. These are our typical, you know, goals we're trying to achieve, meeting the owner's needs, making sure that stuff doesn't deteriorate earlier than it should, optimizing energy performance. I think now, you know, I've seen lots of empirical data of, you know, the increased efficiencies required both by AEC and other code-related things. So we need to confirm that energy performance, the timely turnover. What is timely, and how much of that commissioning documentation and what format is it turned over? And we want to make more effective building operators, right? We want them to know and understand their buildings. Buildings are not mass-produced. Every building is an organic machine. It's alive, and, you know, yeah, we apply some common practices from certain systems to building, but in reality, that building is its own self. And so this graphic on the right side is a very common graphic you see out in the industry, essentially related to the fact that the initial design and construction is only a quarter of the total building costs over the life of the building. And that as it gets older, right, yeah, good cost in the first 25 years, and then the older the building gets, the more it costs to operate. And so, you know, for goals, we're hoping that if those goals are met, those benefits come through, both in finding issues earlier, both in the design phase and trying to, you know, help in the construction issues of changes. We don't get much changes in construction these days, right? Change management is a real simple process. No, it's not. As far as the controls and building systems and how they're operating, that they need to be maintainable and hopefully last long, and hopefully in the reduced warranty callbacks, the intent is in the warranty phase. We're not arguing about stuff that hasn't been figured out. We got to get all that done on the side of construction to get things completed and have a more effective warranty phase. So again, if you're a commissioning provider, this is pretty common in your presentations or your marketing material. What we're trying to, you know, why is commissioning, the building performance and the higher efficiencies required? We're not using less technically advanced equipment. We got to confirm the programming's in there and it's going to meet our energy efficiency needs. How many of you experience where you're helping the building O&M guy understand that his system is not driven by 3 variables? There's a whole lot of things that go into when he changes something on an outside air damper and how it's supposed to react. And for him, that opportunity for us to talk to him and confirm, hopefully affect the long-term performance. Identifying unfinished MEP and fire life safety. I think as a commissioning provider, I've really recognized the, you know, that whole, how the turnover happens with the CM getting the AHJ to sign off and get his TCO, and boom, everybody moves in, and we're struggling to try and figure out how we wrap things up. But as far as how important those systems are to be finished and being operational and correct before load and people start coming on is very important. We're hoping that the commissioning really has, and it has, you know, it has a very big role in completing that project and doing that turnover. And I think the recognition of Juan and his staff and the Energy Management Optimization Group, and you probably have similar things if you have a large client, their need to get that turnover and then really take full operational management of that building is it's not a simple one-day thing. And sometimes commissioning is required because of accreditation, whether it be a hospital, data center, and now, for example, LEED V4, if you want to go after the operations and maintenance certification, once after the building, there's a lot of good stuff there that the owner benefits from. And again, a lot of it relates to the commissioning skill set. So, I use this slide mostly to illustrate, that the new initial commissioning process revolving around the linear project delivery process. We're going from programming through construction, acceptance, warranty. It's very linear in a way of what we're trying to achieve, the project delivery team. But when you look at what we do for existing building, it's very iterative, right? We're going to look at a particular situation, analyze it, make a recommendation, make a change, go back, measure. Did it do what did we get the reaction we wanted? Okay, now let's go on to the next list. How many of us use in the retro commissioning process the language, the low-hanging fruit? A lot of stuff that we find in the BAS that alarms acknowledged and just things that need to get fixed, and then we come back. So I use that to illustrate that this is an iterative process. It keeps going. So, and in the warranty phase, well, I think we're all, as commissioning providers, we're used to, at least if you look at the LEED language, well, what do you do in the warranty phase under enhanced commissioning? You come back at 10 months. What did LEED intend by doing that? My client is LEED-centric, but I have a lot of clients that are not LEED-centric. They're about good process. And I really believe that as far as deferred testing and some of the things that happened, the 10-month meeting was really about LEED saying, hey, before you finish the warranty process or the warranty phase, get input from the CXA to assess the completion of the systems and how they're doing and how you can really have a lot of value there. But is waiting till 10 months really value added to the owner? No, I don't think so. It needs to be more continuous, especially when we just talked about how the load is coming on, things like that. So the recommissioning manual and the monitoring-based commissioning is some new things that have come out that LEED is saying, but as us as comprehensive commissioning providers, I think we're very aware of what the value is there to tell an owner what should you do in a continuous commissioning process. I even say to owners when I go present to them, you might be tired of that word commissioning. You keep hearing it all the time. You're not sure what it is. Let me demystify it for you. And I use the analogy of the shipbuilding. Commissioning came from that. And shipbuilding, a ship that was commissioned went all the way through what's its purpose, properly designed, properly built, properly performed, and 1 year of sea trials. 1 year of sea trials, and that O&M staff of that ship was expected now. They don't have a theoretical design model. They have an operating ship. So by after that 1 year, they were expected to know everything they needed to know to keep that ship operating at top condition. Use that analogy when you explain to owners what the intent of commissioning is. Because that last part, the training, which I consider the most critical in the handoff to the O&M, that's where we're going to go and cover a little bit more on the monitoring-based commissioning point from LEED V4 and how that provided some language. And before I turn it over to John, some of this work a couple years ago came from talking to my client about how we can help that handoff between the project delivery side and the O&M side. And at that time, LEED V4 was not out yet, but it was out for comment. And being a LEED-oriented guy, I was aware they do pilot credits. I was aware of the monitoring-based commissioning. It was a pilot credit. I pulled out the language and I said to my client, why don't we implement along these lines? And now my clients have decided LEED V4 going forward, the monitoring-based commissioning. Yeah, I get a point, but it makes a lot of sense in that handoff. So with that said, I'm going to hand it off to my partner here, John Bixler.
Alex kind of jumped ahead and covered most of my material already. So I'm just going to totally reconfigure the way I'm doing my slides and kind kind of dovetailing off what Alex said, the way the evolution happened with the University of Texas was that they realized that there were a lot of needs that weren't being fulfilled, that they were having a lot of kind of pain and struggle on their end. And what they did, what Alex and his team, in working with them, they kind of slowly put together piece by piece what ended up being basically a kind of a monitoring-based commissioning approach or ongoing warranty support for the first year. That's what Jessica and Adam are going to talk about a little bit more. My job was to tell you guys about the gaps that end up remaining in the commissioning. Oh, first I got to talk about PI, right? So we're back to this slide and talking about our PI. And there's a lot of transitions that happen throughout a design to construction to operations project, right? So that's really where we as commissioning agents live, is in these transitional periods. And really the whole commissioning process is meant to fill in some of the gaps that are left. You know, you talk about you transition an owner's requirements to a design team, and there's a gap there, and our job is to sort of live in that a little bit. There's lots of gaps within the design team between all the different entities that are involved. We're there to help with that a little bit. There's a gap that happens between the design team handing things off to the construction team. Again, we're there to help with that. We're there to help with all the gaps that occur within the construction team between all the different disciplines. And then finally, we're working to try to fill that gap in the construction handoff to the owner, right? So we're doing our best as commissioning providers to fill all these gaps, but some still remain. And so I'm going to talk a little bit about some of the ones that still remain. And again, as we go through this, just think about the way that the ongoing warranty support supports and eliminates some of these gaps. All right, so how many people out there have had a project where an owner's taken control of their building, moved into their building, and some of the functional testing was incomplete? Has that ever happened to anybody? Yeah. I can tell who's not paying attention because they didn't raise their hand. So that's something that just inevitably happens, right? And in an ideal world, we're also handing off a commissioning manual and a commissioning report and a systems manual on the day the owner takes over a building. That rarely happens, right? But that would probably be the ideal time to do it. Alex alluded to earlier how difficult phased projects can be. And even when projects aren't phased, my experience has been that as a commissioning agent, we're asked to take one chunk of the project at a time, right? So if, for instance, we've got this air handler done, go test that air handler, and then 3 weeks later, well, this floor of VAVs are done, so go test all those VAVs, right? And in an effort to help the schedule of the project, we tend to get caught in that trap of thinking that way, right? We get down to component level thinking versus system level thinking. And it's even worse on projects with formal phases, right? Each phase introduces a whole new set of transitions and gaps that we have to worry about. So because of that process, we tend to get to the component level thinking, and we don't get a chance to really analyze systems a lot of times until the owner's in the building. So again, when you think about this from the perspective of ongoing warranty support, that's really helpful for an owner, for us to do more of the system-wide evaluations when we have the opportunities to. Owner training is a really important part of the commissioning process. I think we'd all agree with that, but it's also really difficult to do effectively. With an institutional client, it's especially difficult. There tend to be large organizations that are highly fragmented, so you have lots of individual sections that you need to train, right? So instead of just one point of contact, you really need to try to train and process information to a whole number of different people. And that's challenging, and then it gets even worse when you kind of factor in some of the other gaps we talked about. You've got incomplete training, and kind of a component level focus. So with ongoing support, you get additional touches with all those different people on the client side, and it helps you to deliver a more effective training. Alex alluded to the idea that with University of Texas, they're thinking it takes 1 to 2 years to really fully load a building. I think that's kind of similar with most higher ed clients. You sort of gradually fill the building up with classes, labs, have researchers move in, things like that. But it's important to recognize that every building is different too. We were talking to some of our colleagues here in Las Vegas earlier this week. They were telling us a story about a convention center that was being built here. The convention center was fully booked the day after construction was scheduled to be complete. So the guy telling us the story he phrased it pretty much like this. He said, well, they pretty much turned on all the systems and crossed their fingers and hoped it worked. It's kind of mind-blowing to me that it would operate that way, but the generation of revenue is so important to that entity that they booked it up real quick. So that's an example where the building actually was fully loaded, from day zero, basically. Alex talked a little bit about the fire hose effect. He was the first person I heard use this term, and I absolutely love it. I feel bad for building operators on the day of substantial completion. There's so much that's given to them at one point in time. They just can't handle it. You've got a brand new building you're trying to figure out, operate, see for the first time. You're getting a commissioning report, a systems manual. Buildings have so much data now that you're just flooded with feedback from the building. You also have the huge pile of paper that the design and construction team calls the O&M manual. And it's just too much to handle it for all at once. So this idea of the ongoing warranty support helps to sort of gradually spoon feed that information so you get the information when you need it versus all up front. Again, the transition from LEED V3 to V4, the first time I was ever actually excited to read anything about LEED was when I read the V4 requirements for the first time. I really felt like LEED actually got it. Like, they understand the difficulty that owners have in operating buildings, so they're trying to set up the infrastructure to really help that with LEED V4, in my opinion, with an emphasis on training and particularly with the ongoing commissioning and the O&M plans and those components that have been added. And again, what happened and Jessica and Adam are going to get into this a little bit more with the University of Texas. They had this building that was built, and they were pretty unsatisfied with the energy performance of the building. And so Alex and Jessica were working with the University of Texas and developed a scope for this ongoing commissioning support. It included monthly visits, and then Jessica spent a lot of time really diving down into the performance issues in the building and having meetings with the owner and the operators, and as well as the rest of the construction team. But it was at this same time, like Alex said, that we saw pretty much for the first time the pilot credit for V4's monitoring-based commissioning, and it really was almost identical to what we had been talking about. So we really felt that LEED managed to get that one right as well. And this is a graphic that you see a lot in some of the fault detection and diagnostic presentations and things like that. But really the idea with a monitoring-based commissioning approach is that that you don't let performance degrade over time. Adam's going to talk a little bit more about his job, but I can tell you, that performance degradation that happens over time makes Adam's job a lot more difficult. So trying to set projects up for success right from the beginning with kind of a more involved warranty period approach, and then monitoring-based commissioning is a great way to set Adam up for success. So with that, I'm going to hand it over to Adam.
Thank you, John. All right, so I'm going to do a quick overview of University of Texas. There's about 20 million square feet of building space. And as expected with the university, there's a wide variety of building type. So we have labs, classrooms, housing, offices, public assembly spaces, large performance theaters, etc. It's an old university, so it gets built over time, and so there's a wide range in ages from over 100 years old to brand new. And then UT has a combined heat and power plant and chilling station, so it only consumes natural gas. The university only buys natural gas, and then it provides district chilled water and steam and electricity. So I'm part of the team called Energy Management and Optimization. And so basically what we're doing is providing demand-side energy management of the campus buildings. So as you can see on the right here, this graph, this is time going back to 1930, and this is square footage. So the campus is growing on average by 2.4 million square feet per decade. So what happens is when you have your own power plant and your own district thermals, you have to keep building infrastructure to provide that. And so at some point, we're going to run out of space. They don't want to put any more money into building more utility infrastructure. So my team was created a few years ago to basically work on the demand side and keep the demand side down so they don't have to keep building more utility infrastructure even though they're building more buildings. So our goal is to offset projected campus energy growth by reducing the average EUI by 2% annually. So how do we do that? One of the big things is working with existing buildings, going and doing existing building commissioning. We are mostly looking at HVAC systems, mostly trying to rewrite sequences that were written 20 plus years ago and to get them and to optimize them. So using a lot of the new sequences that people are coming out with today to optimally run the HVAC equipment. Also scheduling other things that go into HVAC commissioning. We also do some behavior programs. So Longhorn Lights Out is basically getting students to turn their lights off on Friday afternoons before the weekend. Horns Up, Sash Down is for labs to get researchers to close their sashes when they're not in their lab spaces. And then new construction. So we help write the standards for new construction and renovations. Thanks. Don't hear me, huh? We do design reviews, mostly looking for energy impacts. And then the big one that we're going to talk about today is target EUIs. And so this is some of the success that we've had going back to 2009. This line is the square footage on the left, how it's gone up since 2009. And then the bar graph is the average EUI. So we've had some pretty good success. So back to target EUIs. So you can see here, we've classified all of our buildings into 5 categories. There's classroom, housing, office, public assembly, and lab. Like I said, we have district thermals, so you can see how it's broken down into the blues, chilled water, that's electricity, and then steam. And so it ranges from office is about 90 to a lab, which is about 275. And it's based on our buildings on campus, built between 1990 and 2014, and we benchmarked it against a bunch of different nationally recognized benchmarks, so CBEX, Labs 21. We basically tried to come up with these custom targets that are appropriate for our system and our campus. So this is our, where we're going to dive into is the new Dell Medical School. So it's a brand new medical school at UT. There's the Dell Seton Medical Center, which is basically like a learning hospital. And then there's 3 other buildings that are used for lab and classrooms and faculty offices. And so we're going to be talking about the Health Learning Building, which is this one down here. So it's a pretty diverse building. It's got a lot of different spaces in there, everything from cafes and student lounges. There's classrooms, there's administrative offices, and there's also some anatomy and simulation labs. So there's a lot of different things going on in this building. And if you remember, we tried to classify our buildings into these 5 types. So when we looked at this building, we were pretty confused about what to put it in. So what we had to do was go and look at the different space types. So it turns out about half is office, about a quarter classroom, and a little bit under a quarter is lab. So we had to do a weighted target EUI, and what we came out with was a target of about 130. And when we looked at the numbers for the building, we were around 180. So one of the challenges in looking at energy use in a new building is, when it first comes online, its energy could be all over the place. It's not running how it normally would. It's also filling up over time, especially at a university. So you kind of run into some trouble of how to take the data, energy use data, and make sense of it, and how is it going to operate normally. So these top 2 graphs are just taking all the data that we had. This is monthly chilled water usage and monthly hot water usage. I guess I should mention there's a steam to hot water converter for the medical school. So instead of steam here, we got hot water. So, and this is heating degree days and cooling degree days. So the chilled water use looks pretty good. Hot water use is looking really funky because you got this point way up here and this point here that are kind of outliers. It's, doesn't look too good. And so it turns out, when we go and look at the data, that these 2 points here actually line up with these 2 points, and they were the first 2 months of data that we had. So if you pull those data points out, you end up with these really nice trend lines correlating heating degree days and cooling degree days to chilled water and hot water use. So that's just to highlight a challenge in analyzing new building energy use. So what happens is, like I said, we have a target of about 130. We are seeing EUI around 180. And so when we went through the project with NV5 that Jessica is going to go into the details of, we were able to get our EUI down to close to our target. And we'll come back to this slide later to get into the details. So I'm going to now pass it off to Jessica.
Thank you, Adam. So I'm going to give you guys a brief overview of our process, and then we'll dive into a couple of examples. We chose the examples in an attempt to give you guys a variety. So they're not necessarily representative of the changes that had the greatest impact in energy reduction. So we began by evaluating the existing current conditions of the building, and that including going through the building automation system, doing some field visits, some troubleshooting, evaluating the program sequence of operations, and looking at trend data. From the analysis, we were able to develop 27 recommendations that we provided to the team. The team included the construction manager, controls contractor, engineer of record, as well as the utilities and energy management group from the university. They've accepted about 25 of the recommendations, and the controls contractor went ahead and implemented them. After that, we came through and we re-functionally tested all of the affected systems to verify that they were functioning properly. We gave it a couple of weeks, and then we were able to look at trend data to verify that they had the impact that we were looking for. We came back after that on a monthly basis and did minor changes and did some fine-tuning of the building. Okay, so we're going to start with the discharge air temperature. We have two identical air handling units on opposite sides of the building, and they were resetting their discharge air temperature based on a linear relationship with outside air. We recommended a reset based on a cooling demand, meaning if a space temperature was greater than its effective cooling set point plus 1 degree, that would send a cooling request to the air handler that if it accumulated 3, it would start to reset down, and if the spaces were satisfied and we had a total of 0 cooling requests, that would start to reset upwards. The building responded very well to this change. So next we have a heat recovery pump, and this is for the anatomy lab that Adam talked about earlier. It has its own dedicated air handler unit with the heat recovery pump. The pump was turning on when the outside air temperature was greater than 78 degrees, as well as when it was below 48 degrees. We recommended that they change that to the 2 conditions that are outlined below, when outside air temperature became greater than exhaust, as well as when that delta was greater than or equal to 5. And we decided on this because we were seeing the returner temperature from the anatomy lab was much colder than the rest of the building. So we were getting a returner temperature of about 66 degrees, and that was definitely an opportunity for savings. So next we have the makeup air unit. This is a unit that feeds air into those 2 air handlers we talked about earlier. This one had a preheat discharge air temperature set point of 53 degrees. So that was what was controlling that. If I can do this clicker, that reheat coil or preheat coil. By the time it got out to the units were seeing about 55-degree air. We recommended that that be changed to 50-degree discharge air temperature set point. Because once the units mixed that air with the returner from the building, which was about 72, 73 degrees, we were seeing in mid to high 60s for the mixed air temperature, and then the cooling coil had to re-cool that air back down to the temperature of that unit. So we were definitely seeing some of that simultaneous heating and cooling. The next example that we have is kind of a trivial one. I mean, everybody has seen a unit that's driving, or an air terminal unit that's driving an entire unit. What we saw here was a space that had changed purpose. This wasn't intended to be an IT or control room, but it became that, and the box that was in there couldn't maintain that colder set point. We recommended that they remove it from the static pressure reset program as the short-term solution, and that they install a fan coil unit dedicated to that space, as that is what the university typically likes to do with those spaces. And then I'm going to pass it on to Adam to close up for us.
Back to this slide, as promised. This is just to highlight the success of the post-occupancy commissioning that NV5 did. So again, our target, you can see numbers on the right. If you like numbers, you could look at the bars on the left if you like colors and pictures. So our target, which was 126, and we were at 188 EUI. We got it down to 143. So just above the target. You know, this was like a custom target EUI, so that we kind of had to make up and fudge some numbers with. So we're pretty happy with that. And so we were able to reduce the total building energy use by 23%. And the big one was almost half of the hot water use was eliminated, 46%. 6% electricity and 18% chilled water. So very successful. And then we'll just put this up for the end, revisiting our learning objectives. Hopefully you guys learned all that you're supposed to. And so now you can take questions.
So I have a two-part, wow, it's loud. I have a two-part question. When you do your EUI, are you using gross square footage or net usable square footage? And if you're using gross, how do you assign mechanical and common areas when you're doing that?
So we basically look at conditioned square feet. So we exclude any parking garages, parking levels, anything. But we do include mechanical rooms. If it's within, it's basically conditioned space, even if it's not directly conditioned. So it is included. Did that answer? Is there?
Transit areas.
Oh, like how do we classify it?
Yeah.
So 90% of the time we are just looking at whatever the main use of the whole building is. So if it's mostly classrooms, then we just call it a classroom building. We don't divide it up. This was kind of a unique case just because it had so many different space types. So that bar graph that I showed, I actually excluded the common areas and the corridors and just looked within the spaces that I could define. I just used that. So within the 80% of the spaces that actually fit into one of those categories, that's how it worked out.
A couple questions up here.
Yeah, well, it's great to have a client that's that interested in getting the performance that's in their OPR, and it's great that you got a team that is willing and able to delve in and solve some of these issues. Does this, that's kind of an ideal world. Most of our projects have limited time, limited budget, and it's kind of like turn it over and be gone. Is this a result of the LEED V4 requirements? Could you maybe talk about how we could in our practices get this kind of follow-up and you really complete the whole cycle, if you will?
Watch out, I got a low voice. Let's just say, part of our challenges is we're working for the project delivery team and they hold our contract. And they have a pool of money, and then the O&M guy, he has a different pool of money. I think this really resulted from again, the discussion from the project delivery team realizing that they didn't want the O&M team to not have extra support, because when we turn over the building in warranty phase, we don't want to create more opportunities for claims by the contractor, right? That it wasn't being operated correctly or that it wasn't being maintained. And so I think what I ended up being able to accomplish, because of the skill set that we have and the discussion that we know the building as the commissioning authority, we know those systems. So I think between the project delivery leadership and the O&M leadership, they recognized that let's not quiver over the dollar value, because really we're talking about an 8-hour visit a month. It's not really as huge a cost impact, but the value impact is tremendous. And I think that was where I got the two guys to realize that. And that is a challenge, and it's some tact that sometimes is not really easy in that getting those two sides to communicate a little bit more. That's the best answer I can give you. But remember, we're bringing value. We're trying to really help that O&M. That's one of our key roles as a commissioning authority.
How re-engaging the project team, you mentioned controls contractor, engineer record, so forth. Did you have to basically pay an extra to the controls contractor to come back in and rework these sequences, rework their set points and so forth?
I think some of it was facilitated. This was a project like everyone else. We weren't totally finished, right? We were still waiting for some corrective actions from the controls guy. But I think in the institutional client standpoint, we all want to have long-term relationships here. So I think that kind of drove them as well. They were very receptive when it came to calling the meeting. In fact, that was the thing I said to the UT project manager. I'm going, you know what, we'll go over there and we'll look at it, and we're going to call a team meeting. And everybody showed up. Everybody and the engineer was sitting there just going through the recommendations. We went through it, and by the time the meeting was over, everybody knew what was going to happen in terms of him going to do it. So it never, but I can see your point. It can be a real challenge, because at substantial completion, what typically happens? Boom, project delivery team is gone. So.
Hi, I have a two-part question. The first part is commissioning isn't required in Texas, correct?
Did you say commissioning is required?
Is it a requirement or is it not?
Actually, now commissioning has been codified through energy code, so it is different. Again, today's discussion, we've been talking about our lead-centric client, but commissioning, yes, in most parts is required if you're working for governmental type agencies like higher eds as well.
Okay, and then my second part was, what was your biggest challenge in the discussion for the need of commissioning on this project and, you know, doing the post, the pre, the warranty?
Well, this owner is very progressive in a lot of things they do, both you know, as far as having commissioning as a part of what we do on all of their projects. They just understand the value. They also have a tab company that does all of their work, so they really understand that that's part of the process. It is not seen as a, you know, as a soft cost, something that they have an option for. They really understand we're helping the design team, the construction team, the owner team. It's very much a gap filler role, but it's very necessary. Any other questions? We got a couple minutes. If not, we really thank you for your time. Hopefully we gave you some tools, and we'll be up here if you want to chat with us. Thank you very much.